All right, welcome sixth graders. Today, while we are working through, we're going to do a review of what prime factorization is. You can grab your Doodle notes that looks like this page and fill it out as we're going. Remember to pause the video when you need to rewind, re-listen, and then just get your notes down as you go. So a prime number is a number that is greater than 1 and has exactly two factors, 1 and itself. So I want to make a special note here that the numbers 0 and 1 are not prime. Okay. Some people ask why we bother with learning about prime numbers. So remember, the reason that we look at prime numbers is because eventually what they are is the building blocks of all other numbers. Kind of like people each have unique fingerprints, each number has its unique prime factorization or its own unique fingerprint, if you will. So when we're looking at prime factorization, there's a couple different strategies that we can use. The first strategy is probably going to be newer. Most people haven't seen this one. This is called the ladder diagram. The ladder diagram can be really nice because it leads into some strategies that we're going to be using for some other things this year. The things that I don't like about it is it's a little bit more restricted in how you apply it. So right now we are going to look at using the ladder diagram to find the prime factorization of 600. So 600 is going to be the number that we put in that top box. Then I'm going to look at what is a prime number that I can divide 600 by. If you remember back to our divisibility rules, it's an even number, so I can at least divide it by 2. So I'm going to put 2 on the outside, and then 600 divided by 2 leaves me with 300. So I'm going to put 300 on that next ladder down, and I'm going to repeat that process. So once again, it's an even number, so I could divide by 2. So 300 divided by 2 gives me 150. 150 is even again, so I could divide by 2. 150 divided by 2 is 75. Now, 75 is no longer even, but since it ends with that 5, I know it's divisible by 5. 75 divided by 5 gives me 15. 15, once again, ends with a 5, so it's divisible by 5 and leaves me with a 3. And then our prime factorization is just all of these numbers that we have on the outside. So our prime factorization becomes, 2 times 2 times 2 times 5 times 5 times 3. The second strategy we can use is one that people are more familiar with, and it's called the tree diagram. I like the tree diagram because it gives you a little bit more flexibility. So once again, I'm going to start with that 600 at the top, and now with the tree diagram, I'm just going to draw 2 branches, and I'm going to think about what is something that 600 could be divided by. Well, maybe I'm going to start the same way, and that's an even number. So I'm going to take 600 and divide it by 2, and that leaves me with 300. So what I like to do is draw a circle around any of my branches that end in a prime, and then I continue my branches off of any of my composite numbers. So here I could choose to do 2 again, Or maybe I look at it and I said, oh, well, 300, I know could be divided into 3 and 100. Once again, 3 is a prime, but 100 can be broken up. Now maybe I know that 100 is 10 times 10. In this case, I didn't use a prime number because 10 is not prime. So then I can break up my branches of 10. And I know that 10 is really 2 times 5 for both of those. And now all of my branches are done. If it helps you, sometimes I have students that put that multiplication symbol in there so that they remember that they're using multiplication and not addition as they work their way down. If you look, each of these numbers goes along with one of the ones that we found in the ladder diagram. So even though we used a different strategy, all of our numbers are still the same. And in the end, our prime factorization is 2 times 2 times 2 times 5 times 5 times 3. Or we can rewrite it using exponents so we're more efficient. So it becomes a factor of 2, which is used 3 times, times a factor of 5, which was used twice, and a factor of 3, which was used once, but because it was just once, we're just going to leave that. All right, so let's look at one more example, and then I'm going to let you do 2 on your own to check. So let's look at the prime factorization of 32. You can either use the ladder or you can use the tree diagram. I'll be honest, I typically use the tree diagram for prime factorization, but you are welcome to do either. If I look at the tree diagram, I'm going to think about what are 2 numbers that I could take 32 and divide them by. So what are 2 factors of 32? I might use 8 and 4 because 8 times 4 is 32. I could also use 16 and 2. So anything that you can think of that equals 32. So I'm going to use 16, or I'm going to use 8 and 4 because those are the first 2 that I thought of. Neither one of these happen to be prime, so I'm going to break these down further. 8 is the product of 2 and 4, and 4 is the product of 2 and 2. So now 2's are all prime, 4 is not. I can break that down further. So this becomes 2 times 2. So my prime factorization of 32 becomes 2 times 2 times 2 times 2 times 2, or the more efficient way, the only factor is 2, but it was used 5 times, so 2 to the 5th power. So what I'd like you to do right now is pause the video and try 132 and 144 on your own, and then seeing how you do when you restart the video. All right, I'm going to go through this a little bit quicker than I did the other ones. So 132, I'm not as familiar with factors of 132, but I know because it ends with a 2, it's even. So I'm going to take 132, divide it by 2, and I get 66. 2 is prime. 66, I know I can get with a factor of 2 and 33. And then 33 has a factor of 3 times 11. So my prime factorization is 2 times 2 times 3 times 11, or 2 to the 2nd power times 3 times 11. 144, I know is 12 times 12. And then 12, I'm going to do 2 times 6. Could have also done 3 times 4. 6 is going to be 2 and 3. So 2 times 2 times 2 times 2 times 3 times 3, or 2 to the 4th power times 3 to the 2nd power. So remember, either of these is correct. You can either use the written out or the exponents, but in the standard we are trying to get to the point where you're using exponents to express your prime factorization.